Hey, what's up everyone? It's Tamimi from Solace. If you missed out on our first episode of the Solace Community Lightning Talks, don't worry about it, I've got you covered. Our first talk featured Florian, a developer from the community, who talked about lightweight messaging using Spring Cloud Bus and Solace. In his talk, he goes over a short architectural introduction about Spring Cloud Bus and works his way towards a demo and a cloud-based use case. Check it out, and don't forget to leave your comments and discussions on our community thread on solace.community. First speaker for the day today, Florian will be talking about a lightweight messaging with Spring Cloud Bus. So I will introduce Florian to this stage. Florian, how's it going?
Thanks, Tamimi. I'm fine.
Good, good. I'm so glad you're joining us today, and the topic that you're going to be talking about is pretty interesting. Where are you joining us from, Florian, by the way?
I'm based in Germany, south of
Germany. Okay, awesome. Well, the stage is yours. Feel free to share your screen. So your screen is shared. I will go ahead and stream it. And as people are coming in, I will be highlighting them where they're joining us from. And we have old friends joining us as well, which is great. So Florian, the stage is yours.
Great. Thank you very much. So welcome everybody to this first talk of this series. It's going to be about lightweight messaging with Spring Cloud Bus and Solace. And basically, to get you well informed about what Spring Cloud Bus is, I try to summarize quickly what it's about. And this is a quote basically from the documentation of Spring Cloud Bus. So Spring Cloud Bus links nodes of a distributed system with lightweight message broker. And this can then be used to broadcast state changes or other management instructions. So very important to highlight here is it's a lightweight message broker. It's a lightweight messaging bus, if you like, that can be used for more or less transient information that is distributed among nodes in the network. But it can not only be used to broadcast messages, but it can also be used to directly address nodes in the network. It's based on Spring Cloud Stream, which is quite a nice technology out of the Spring Cloud stack, and which abstracts different messaging technologies that you see down here at the bottom. So you can imagine Spring Cloud Bus sitting on top of Spring Cloud Stream, which is an abstraction on top of RabbitMQ or Kafka, or in this case, Solace PubSub Plus, which I'm using for this talk. So Spring Cloud Bus is basically based on the very common and well-known concept of application events that you have in Spring. So if you write a Spring application and you have several beans inside of that application that require to get feedback about the application lifecycle, or that want to exchange information in a, let's say, in a loosely coupled fashion, then what you can use in a Spring Boot application, or in a Spring application in general, is the application events. And what you do is basically you write your bean, you annotate it with the @EventListener annotation, and you implement a method that will receive an application event. And if you have bean A communicating with bean B and sending events that bean B should receive, then you usually do that via the Spring context. So using the Spring context and application events, which is a class that Spring Boot and Spring introduced, you can send messages back and forth between your beans within the same application. Now that mechanism is something that Spring Cloud Bus uses to actually send messages across applications. So imagine now there's a second application, and it also is set up the way the first one was, but it's in a remote place. It's on another network node or something. And now you introduce Spring Cloud Bus into that application setup. So you add it to your POM XML if you're using Maven. And what you basically establish like that is a channel based on top of a message broker, like Solace in this case, that can connect the two applications. And what Spring Cloud Bus does under the hood is it auto-wires an additional bean into your application, which is yet another event listener, And I call it remote dispatcher. I think internally it's called a bit different. But it's yet another event listener that is attached to the application context. And that is now listening for particular events of type remote application event. And remote application event is a subclass of application event. So it's using the Spring mechanisms. And whenever a remote application event is sent from within an application, that remote dispatcher will receive that event, and identifying it as a remote application event will know that it now has to send that event through the Spring Cloud Bus abstraction layer and via the broker to the remote end. That's pretty much all there is to Spring Cloud Bus. It's quite a neat little mechanism that wires itself into your application if you add it to your dependencies, and then you're good to go to send messages back and forth between applications. So with that said, let me go to a quick demo and we have a look at this. So what I've done in the background is I've started an application. Basically, I started Solace PubSub Plus, and you can see the entire demo if you're interested in that. Later on, you can have a look at the equality Spring Cloud Bus repository on GitHub, where this whole demo has been wired together and has been also described. So in the background, I've started Solace, and this is the UI of Solace. And currently, you see there are no queues exposed, so they're not available. But I will now go to my console, and I just start two applications. First of all, the consumer application. That is a Spring Boot application that will start up and hook itself into Solace using Spring Cloud Bus and the Spring Cloud Stream binder for Solace. And this consumer started. Now I'll start the producer also. And this is the application that is exposing a REST endpoint, which I can call from the browser to basically just send a message from that via the producer and hopefully receive it in the consumer. So with the producer started, let's go to the browser again and go to that endpoint here of our producer and send a message. So we'll send it to 8001, port 8001, which is where my producer is running, and I send a hello world message. So let's do that. Okay, it's been sent. Now have a look at the output. Producer says event send, as you can see. And if you have a look at the consumer side, ta-da, there the message is. And it was broadcast through Spring Cloud Bus and using Solace under the hood. So that's basically all there is. If you want to know what the code looks like, it's pretty simple. Basically, first thing you have to do in your code, you have to introduce Spring Cloud Bus dependencies in your Maven POM XML. And of course, you have to have the binder, the Spring Cloud Stream Solace binder, so that Solace wires itself under the hood of Spring Cloud Bus to be the main broker to distribute messages with. Then if you have a consumer, you just, as I said before, you just write your consumer by providing a method that will take an event, and you annotate it with event listener. And basically, this will make sure that Spring will fetch any events that are being sent via the context and will input them here into that method. So you can use the event and you can print it. You can use it to process any business logic that you like. As a producer of events, you pretty much do a similar thing. So first of all, here I'm exposing the REST endpoint using this get mapping. But then inside of the REST endpoint, which is being triggered when I'm calling or when I'm using the browser to fire that request, it's basically just creating a new event, and then it's using the Spring context to publish it. That's all there is to it. And if you want to have a look at the event itself, the event is just a subclass of the well-known remote application event, which was introduced by Spring Cloud Bus and which internally is used by Spring Cloud Bus to detect that this is an event that should be sent across the wire and from one node to another. That's pretty much it. If you want to find out more about how to particularly address one node in the network and not just broadcast events, I suggest you go to this link here. This is from the official documentation of Spring Cloud Bus. There they mention how to address particular instances within the, say, the broker network. And you can use that addressing scheme to basically address particular nodes inside of your network, like that. So this was now a very boring, almost I could say, a boring use case. There's much more that you can do with Spring Cloud Bus, which is much more advanced and which is really handy from time to time. And this picture here tries to explain a more advanced use case that Spring Cloud Bus is actually used for by the Spring Cloud stack itself. So if you know Spring Cloud, the Spring Cloud stack a bit more, then you know that there are a few very, very handy components if you want to build up your own cloud landscape, if you like, or service landscape. So you find the Spring Cloud Gateway. From Spring Cloud, you find Eureka Service Registry, which allows you to build services that you see down here that connect to Eureka, and they can find each other. They can detect who is there and what the endpoints are, what their metadata is, and the services can start calling each other and are loosely coupled by registering to that service registry. And another component that Spring Cloud provides is Spring Cloud Config Server. And this is a very handy thing, because imagine now you have your services, each of them being a Spring Boot application, and each of them having their own configurations and an application YAML. So imagine you have to maintain the configurations for each of these services once you've deployed them into the cloud. And that's where Spring Cloud Config Server helps a lot, because Spring Cloud Config Server is a Spring Boot application, basically, which can be wired up with a Git repo. And in your Git repository, you can store all the configurations of the different services that you run in your cloud. And you can just upload them to the Git repository, and Spring Cloud Config will fetch those configurations and will distribute them among the services once you have them running. So when they start up, the services will find config server in the registry and will get their configurations from Spring Cloud Config Server. Now, that said, you would ask, where's Spring Cloud Bus? Well, so far there is no Spring Cloud Bus, because what I just explained is the configurations being distributed among the services down here at application startup. So that's a pretty static approach. Now, if you're running this in the cloud, it's much more likely that at the runtime of these services, you will want to change their configurations. And the cool thing is, if you now change the application YAML files down here, the configurations for these individual services, you can push them again to the repository. And if you now have Spring Cloud Bus in the picture and maybe a Solace underneath, like it's shown here, then what you can do is you can push the configuration changes to a GitHub repository. That's just a git push. And Spring Cloud Config Server, if configured properly, will get that update of configurations and can now take these configurations and use Spring Cloud Bus to distribute them in a message-based fashion among the services that are deployed in the cloud. And that gives you a very nice opportunity to update your service configurations at runtime and refresh basically the state, the configuration state of your services at runtime without having any downtimes. So your consumers will actually not suffer from your services not being available. And that's a more advanced use case. You can have a look at the GitHub repository I mentioned before. There's a second one, which I'll make public soon, which shows this kind of setup. But if you read the documentation of Spring Cloud Config Server, you'll also find out about this. And again, Spring Cloud Bus is at the heart of it. Solace is underneath, making sure that your messages are transmitted properly. And that's the cool things you can do with Spring Cloud Bus. That's pretty much everything I have to say. If you're interested, again, you can go to the Qualities Spring Cloud Bus repository on GitHub. There you'll find everything I just said now. Also upload the slides there, and there you can also find then some references to documentation of Spring Cloud Bus and Spring Cloud Stream and all the other components that I was mentioning today. That's it from my side. Thank you very much. Are there any questions that you would like to know?
Perfect. Thanks for this quick and simple demo. It was very light, like the lightweight messaging bus. We do have one question, Florian, that is coming from a couple questions that are on the chat. The first is asking about Spring Cloud Bus in general. So if Spring Cloud Bus provides an abstraction away from various messaging technology, how simple or complex is the API? And can you do things, other things beside publish and consume events?
Yeah, that's a very good question. And that's exactly where the lightweight part in the lightweight messaging talk comes from. So Spring Cloud Bus is a very high level abstraction on top of messaging. And if you're looking for a, let's say, an advanced messaging case, or if you want to build those patterns that you might know from RabbitMQ world or Solace world, where you have dead message queues and you have time to live parameters in a message to produce a delayed processing of messages. That's not something you will do with Spring Cloud Bus. Spring Cloud Bus is more for the, I would say, for the short-lived messages, like the ones, the configurations that are being sent back and forth. So that's what it's intended for. As to the API, it's rather easy to use. As you've seen, you just create your events and you publish them via the Spring context, and that's pretty much it.
Right. Okay. Perfect. We have some people saying that this is cool, and they'll definitely be looking further into this. Just a quick reminder to anyone who is joining us right now. We are accepting questions in the chat. So if you have any questions, feel free to put them in the chat, and we will highlight them here on the stream. People who joined us late, feel free to let us know in the chat where are you joining us from. So you can see a couple people joining us from different parts of the world. And that's one nice thing about having virtual events, which is something that is pretty cool and you can keep doing. If anybody has any follow-up questions for what Florian just presented, I'd like to show you our Solace community, where we have a general discussion thread over there. And this thread, people could go in and ask questions on things that they wanted to ask about, or if there's anything that they want to follow up, feel free to ask it here, and we'll make sure to look it up. And we are giving out some swag to participants in the chat, and anyone who is asking us questions and active, and they're part of the Solace community, will be giving out some swags. Florian, thank you very much for this. We really appreciate you joining us in our community talk, and we will be giving you a swag bag too, as being part of the speakers for today's event. So stay tuned. I'll follow up with you after. So thanks for this.
Thank you very much for having me.
All right. Have a good one.
You too. Thanks.